Welcome to another BIM video. Today we will explore how BIM can be used for quality assurance in your projects. Let's get started. So the learning outcomes for this video, number one, we'll be looking at what quality assurance is, and then I'll explain the quality assurance cycle, and then finally how to conduct a clash detection in BIM. So what is quality assurance? Quality assurance is defined as quality management that is put in place to ensure that the standard of quality of a project meets the requirements and application of the client and any other stakeholders involved. There are two parts to your quality assurance cycle, and you can see it on the screen in front of you. So you have the documentation that's required, and then the resources that will be needed to allow you to deliver the project in line with the quality level that's expected. So in terms of the steps involved, there are 6 main steps in the quality assurance cycle. Number one, you have to design controls that are embedded in the framework. So what that means is that you need to include a set of standards that are in place to ensure that people involved in the project follow the set of standards and the procedures that's involved at various stages of the project. The design controls would then record any deviation from the plan. So if the deviation results, then a set of preventive and corrective actions can be specified, along with a set of course, equipment or resources that will be utilized in order to correct the deviation. And the individuals and, say, for instance, suppliers that are responsible for maintaining the full cycle, so from ensuring the quality of the product that's supplied, let's say for example, they also need to be recorded as part of the cycle in order to make sure that you can track the people that are responsible for specific deviations from the plan. An important application of quality assurance, as I had described, is ensuring that you have correct materials that are ordered for your project. How can we achieve this through the help of BIM? Well, I'll demonstrate that to you. An effective approach is to use this shared parameter function in BIM. So specifically, you can assign a set of fields to track information regarding materials that are associated with each object in your model. Now, the fields can track information including suppliers from which the materials were ordered, the ID or reference associated with that material type, and this is going to be important because, say for instance, you want to keep a record of the paint color that you have in your interiors, and you might, in the future you might require to renovate the building, and as such you would need the same paint color to be used, let's say for example. So it's important to have a record of that material ID. Other fields that you can include as well as part of your shared parameters will be the delivery status of specific materials that are related to objects in your model, when payments are due, and the area of storage on a construction site. So you're sort of trying to embed this quality assurance cycle within BIM. In addition, based on the delivery dates that you have in the shared parameter fields, what you could do is you could connect a delivery schedule to track late material deliveries, and then you can visualize that using 4D BIM just to see the impact on your construction progression. Next, I want to describe to you how clash detection can be performed in BIM. Clash detection is a very important process because it allows you to visualize situations where two parts of the building would be interfering with one another at the same time. Now, through conducting a clash detection, you would be able to move parts that are involved to make sure that this doesn't impact the progression of works. Let me give you an example to make this clear. So, for instance, say you've got plumbing pipes that clash with, say, a particular structural beam that has to go on one of the levels in your project. Here, you would need to understand where that specific clash takes place. Specifically, this is important if you have a very big construction project with a lot of beams and a lot of pipes. And then you need to look at what sort of remedies you need to undertake in order to avoid that clash. And that can include maybe diverting the plumbing pipes or locating the beam somewhere else that is feasible. Clashes will lead to the need for variations in the design or in the construction sequence of a project. Now, early detection is important because it allows you to vary the design when it is less expensive to do so at an early stage of the project. So remember, any design changes that have to take place later on, once construction has started, it will usually be very costly for implementing such changes, and we need to avoid that. Common clashes take place between the following disciplines in a project. So you've got clashes that take place between architecture and structural, or between structural and mechanical, or between architectural and mechanical, or between mechanical, electrical, or even between, as I showed you in the example, I had explained the plumbing and your structural. So any of these disciplines, their models, when it's all integrated into that one platform, you can get a clash of the objects taking place. It's important to precisely locate where that clash takes place so that you can come up with a solution in order to avoid that. Now I'll explain to you, just so that you can appreciate how BIM is very helpful when it comes to clash detection, the difference between a traditional clash detection versus how it would be conducted in BIM. Starting off with the traditional approach, what you would typically do is you would overlay the 2D plan drawings on a light table, and then you would try to envisage them in 3D space. So it's a very complicated process because you don't have any visuals regarding heights of objects. You have to have separate plan drawings for each of the disciplines that are involved. And because of all this information and all the drawings that you need to be analyzing at the same time, you can get, you can have issues in terms of misunderstanding and oversight, and that can mean that clashes are only detected on site during the construction process, and this is going to be too late because it'll be super expensive to resolve the clash. Now, compare that to using BIM. BIM, in a lot of BIM software, you already have an algorithm that will allow you to automatically detect the clash. So what happens is you integrate all your designs into one core model, and then you run the algorithm, and this leads to improved visualizations. You can specifically visualize where the clash takes place. Conflicts between objects can be automatically detected by running this algorithm. And it also permits you to change designs, so to flag certain issues and assign them to individuals that are responsible for changing the designs of a specific discipline. And as such, because you're able to report these clashes, what happens is that you get the ability of enhanced communication, so you can communicate clashes better between the relevant parties that are involved. Now, through using BIM for clash detection, you reduce the risk for your client because you're able to detect more clashes and you're able to resolve them before you actually start your construction project. So you avoid a lot of cost overruns and you ensure the quality of the project. It's a very easy procedure to conduct in BIM. So what you have to do, specifically if you're using Navisworks, the first thing that you would need to do is, of course, you need to append all the models together in Navisworks. This is where, for instance, you would get your mechanical model and your structural model and place them so that you set the position of the models in accordance with a common reference. And that reference is usually used it's usually the reference that's adopted by the architectural model. So you reference everything in accordance with the architectural model. Then you would run the clash detection algorithm, and then that would highlight the objects that would need to be sort of looked at in order to resolve the clashes that are reported. Now in Navisworks, you can also generate a report automatically with a list of all the clashes. And these can be assigned to various team members to resolve, and the status of the clash can also be revised once the issue is resolved. Okay, so that was all for this video. I do hope that you now understand how BIM can be used for quality assurance and how we can utilize BIM specifically for clash detection. Very soon I shall see you in another video. Until then, farewell.